Hey everyone, welcome to my YouTube channel. Let us succeed. In today's videos, let us learn about number systems, which is going to help you for every competitive exam like prize, which are called whose notification is going to be announced soon, and gpstr, hstr, ctet, and tet, everything. Okay, let us move on. Now, introduction. I think no need to introduce about number system because from the lower classes we have come across studying number systems. Mm, and we already learned about natural numbers, whole numbers, integers, and rational numbers, irrational numbers, etc. And we in ninth standard we mainly focus on rational and irrational numbers. Before going to rational and irrational numbers, let us recall the number systems which we have studied in our previous classes. Now, for the first, we'll go to natural numbers. In the beginning, we will study about natural numbers. That is, we already know that what are natural numbers means counting numbers only. Counting numbers like from 1 to infinity, 1, 2, 3, so on, like infinity are called natural numbers and it is denoted by capital letter N. For examples, 5 apples, 10 students, like that. Every number which we use for counting are called natural numbers. Now comes the whole numbers. Whole numbers are nothing but natural numbers, but here we have one more extra number, that is 0. Natural numbers including 0 are called whole numbers, and they are denoted
Those
by
are
capital W. So the integers are the collections of positive numbers, negative numbers including 0, and these numbers are denoted by capital Z. And now comes the part which we are going to focus more on. Those are rational numbers. Rational numbers, irrational numbers together are called real numbers. What are rational numbers? Rational numbers are the numbers which are written in the form of p by q, where q not equal to 0. Means if we write 0 in the denominator, it is not defined. 0 can be, p can be 0, which is equal, if the p becomes 0, that will be equal to 0. That number is going to be equal to 0. So all those numbers which can be written in the form of p by q are called rational numbers. For examples given here, 1 by 2, minus 3 by 4, 5. So here I have written 5. It is not in the form of, you may ask, it is not in the form of p by q. But it is, 5 can be written as 5 by 1. Here p is equal to 5 and 1 is equal to q. So from this we can say that every uh, whole number or integer and natural numbers are rational numbers. Now comes the irrational numbers. All those numbers which can't be written in the form of p by q are called irrational numbers. And how can we differentiate between rational numbers and irrational numbers? This question arises now. Here I have given an example of root 2 and pi. These are irrational numbers. Um, how can I say a number is rational or irrational number? Let us see. We have one method, that is decimal expansion. I told you earlier, before that I told you earlier, real numbers are it is a combination of rational as well as irrational numbers. Both together are real numbers. There are no such real numbers, any different set of numbers which are called real numbers. They are the collections of rational or irrational numbers, and rational and irrational numbers. So, if we consider these numbers too, those are natural numbers, whole numbers, integers, rational numbers, irrational numbers. So, we will get every number on a number line. So, we can say that every point on a number line is a represents a real number. Real numbers means um, either it is rational or irrational number. Rational numbers itself consists of all the numbers from the natural numbers, whole numbers, integers. Every set of numbers comes under rational numbers and irrational numbers. Number line, here comes the positive integers. Here comes the negative integers. And we can see that between any two integers, there are no other integers, or between any two natural numbers we can't, any two consecutive natural numbers, sorry, if we consider any two consecutive natural numbers or whole numbers or integers, we can't find any numbers in between them. Means any natural number or whole number or integer between them. But if we consider rational numbers, now we know that even 1, 2, 3, -1, -2, 0 are rational numbers. Even between them also we can find rational numbers. For example, 0.5, that is 1 by 2, comes under comes between 0 and 1, right? Like that, is the only number, 1 by 2 is the only number that comes between 1 and 2? No, there are infinitely many number of rational numbers between any two rational numbers. For example, if I can, how could I find any rational numbers between two rational numbers? Means if I want rational numbers between 1 and 2, what should I do is, we should consider 1 plus 2 by 2, that is equal to 3 by 2. Now again I want a few more numbers, means 3 by 2 plus 1. This is between 3 by 2 and 1. We should again divide this by 2. Now on simplification we will get another number. Or else I we have one more method, that is, if I want 5 rational numbers between 1 and 2, what I will do, this is another method. One method is taking those numbers and dividing them by 2. Another method is, I want 5 rational numbers between 1 and 2. 1 and 2. For that, I will add 5 since I want 5 rational numbers. For that, I will add 1. I will get 6. What should I do? I have to multiply both 1 and 2 by 6, so that I will get and make the denominator 6. So that, what should I do? I will multiply by 6. If I multiply this by 6, I have to divide them by 6. And for 2 also I have to do the same thing, multiplying by 6 and dividing by the 6. What I get? 6 by 6, and here 12 by 6. Between 6 by 6 and 12 by 6, I'll get 7 by 6, 8 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6. So this is another method where we will make the denominator same by multiplying and dividing by a number. How many that number is how many rational numbers we want, and by adding 1 to that. Hope this point is clear. Next we will move on to decimal expansion. This method is going to help us to identify rational number and irrational number. How can we say a number is a rational number or it is an irrational number? We can say them by doing decimal expansion. Now, here, observe here, if I consider a number 1 by 2, its decimal form is 0.5, which is terminating. Means after decimal, the numbers are going to stop. If I consider 1 by 3, I'll get 0.333, so on. I am not going to get any reminder 0. And root 2, I'll get 1.4142, like that. Here, if I observe in 1 by 2, I'll get 0.5, which is terminating. Recurring means after decimal, the number is going to be repeated. Here, 3 keeps on repeating. If I go for root 2, here 4142. After decimal, we have 4142. So, you may say that 4 is repeating. So repeating means it should not be, repetition should not be a single number. It should be collection of the numbers. Set, it should repeat as a set. If I consider 4 1 should keep on repeating. So this is not ending also, as well as not repeating. Any set of number is not repeating. By this we can say that if the decimal expansion is terminating, and if it is not terminating, it should be recurring, then those type of numbers are called rational numbers. If in decimal expansion, if we get the quotient which is not terminating as well as non-recurring, those numbers are called irrational numbers. Here from the textbook I have taken some few examples. Decimal expansion, this is, here the question is that show that 0.333 so on is a rational numbers, or the question may be like express this as in p by q form, or find its rational form. So for that, what we have to do is, here one thing we have to observe that after decimal point only the number 3 is getting repeated. So now, since one number is getting repeated, I have to take 10. If two numbers are repeating, I have to take 100. So, three numbers are repeating means I have to take 1000, like that only. Here, only one number is repeating, that is 3. That's why I have to multiply the x. If I take a number as x, I have to multiply that by 10, so that I'll get 3.33. If I now, next step is what should I do means, Here, after taking 10x is equal to 3.333, what I have to do is I have to write them in this form. I have to make this number which we have taken as x as separate. To obtain that number 0.33, I have to remove 3 from that. So that I can write x, obtain x. That's why I have taken 10x plus 3 plus 0.33. Now, so that I can write 10x equal to 3 plus x. If I take x to the LHS, I will get this form. So after taking that, 10x minus x, that is 9x, which is equal to 3, and x equal to 1 by 3. So show that 0.33 is equal to 1 by 3. Hence proved. Here x is nothing but 0.33, and which is equal to 1 by 3. That is here. This is also similar example like in to the previous example. Here we can observe that two numbers are repeating. After decimal point, since two numbers are repeating, I have to multiply the x by 100. So here I have multiplied x by 100, and I'll get 127.27. Hereafter I have to make an equation such that I have to obtain x from this number. So what is x? X is 1.277. So that to obtain 1.277, I have to divide it as 126 plus 1.2727, like that. So that I can make it as 126 plus x, and after that I have to take x to the LHS side, and I'll get 99. X is equal to 126, and taking 99 to RHS side, I'll get x equal to 14 by 11. Next we will move on to operations on real numbers. If I add a rational number to the irrational number, I'll get irrational number again. For example, if I consider 2 plus 3 root 3, I'll get 2 plus root 3 only. And multiplying rational number to the irrational number, again I'll get irrational number. If I consider this example only, 2 into root 3, I'll get 2 root 3, which is again an irrational number. Now we have studied about laws of exponents in earlier classes. Now we will going to apply those laws of exponents to the rational numbers. This is same thing as we have done to the integers, whole numbers and natural numbers, like that only, similar to them, but we are going to have rational numbers in between them. Now write decimal form of 30 exercise questions. These are exercise questions. Decimal form of 36 by 100. What is its decimal form? This is 0.36. Express 0.99 in p by q form. This is again similar to the examples what I have showed you earlier, that is 0.33. Since it is only one number is recurring and non terminating, it is similar to the first example I have shown you. Try solving this. Okay, if you want me to solve all the exercises, comment in the comment sections. Now find irrational numbers between 1 by 7 and 2 by 7. Find irrational numbers between 1 by 7 and 2 by 7. I have told you two methods. One is by making the denominator same, and one is by dividing the sum of these two numbers between which we want other rational numbers. This question should be rational numbers, not irrational numbers. Now we will move on to another few more exercise questions, that is classify numbers as rational or irrational numbers. How can we classify a number as rational or irrational number? One thing we have learned is about by decimal expansion, or else we can um, say them by looking at them easily. Now another question is rationalize denominator of 1 divided by 2 plus root 3. Now these are also important questions. How to rationalize the denominator means 1 by 2 plus root 3. So what I have to do is taking the opposite sign between the denominator, 2 minus root 3, and if I dividing that by 2 minus root 3 means I have to multiply the numerator by 2 minus root 3. What I will get? 2 minus root 3 divided by 2 square minus root 3 whole square. How I wrote this means by laws of exponents. I told you in earlier slide that laws of exponents, that is in the form a plus b into a minus b, which is equal to a square minus b square. So this is in denominator is in this form. So I have written 2 square minus root 3 whole square. So our intention is to rationalize denominator only. Numerator will be irrational number only, that is 2 minus root 3, and in denominator we will get 2 square means that is 4 minus root 3 whole square, which is equal to 3, and I will get 2 minus root 3 divided by 1. So we have rationalized the denominator. And third question is also similar to this, that is not similar to that, not to rationalize but to simplify the, we have to simplify the given numbers, irrational numbers. Now this is the third question is also in the form of a plus b and a minus b. A plus b into a minus b, what we will get is a square minus b square, that is here root 5 whole square minus 2 square, which is equal to 5 minus 4, which is equal to 1. Hope you understood all the topics what I have explained. If you want me these classes in Kannada also, I will in upcoming days I'll try to make videos in Kannada too. Now we'll move on to next things, that is location of irrational numbers. I think this is not necessary for hstr as we have only objective type of questions. Mm, it hope you understood all the topics today. Since it is my first video, I need to refine my way of creating videos in my upcoming days. For that, I need your support. Please like, share, and subscribe, and do follow my YouTube channel. Thank you all.